A finite state machine is perfect for simple AI. Hello and welcome back to another Unity Tiny video, where we will be setting up a finite state machine to control the behavior of our AI entities. If you've never used a finite state machine, it's a way to control the flow of your code through different states, allowing for your AI to perform different actions depending on if it's leaving a state, entering a state, or if it should run an update function continuously for the current state. For the project we are working on, this will be perfect. We will be setting up a state machine where our AI will patrol left or right until hitting a wall or a hole in the ground. Then, they will turn around and patrol back the other way. The AI will continue in this state until the player character is spotted, in which case, the patrol state will be left and the AI will enter the attacking state and start to attack our player. They will then stay in that state until either the player dies or leaves the AI's field of view, returning the AI back to its patrol state if available. The first thing we'll want to do is go into our components folder and create a new component called an AI state. This component is going to be an enumerator component. We'll name it AI state, and on here we'll give it 3 states, one idle, another one named patrolling, and the last one will be named attacking. We'll now add the AI state to our AI component. So just search for AI state, add it, we'll name it as state with a capital S, its default value will be idle. Now we need to add the patrolling component. This one will be a regular component, so we'll create it, we'll name it patrol. And on here, we'll add a new field called direction, and it's going to be an int8. And what this is going to store is the direction that we are currently patrolling in, so a -1 or a +1. Let's name it direction. Let's now go into our AI input system and start reworking it to work with a finite state machine. The first thing we're going to do is set up the functions for the finite state machine. The functions we're going to need are a change state function, an onState enter function, an onState leave, and an onState update. Let's go ahead and create those now. So outside of our onUpdate void, we'll say static change state, and inside of the change state function, we're going to ask for a world, which is a ut.world, an entity, which is a ut.entity, an AI tag, which is a game.ai, and a state, which is a game.ai state. Now inside of here, we're going to confirm that we're not already in the state we're trying to change to by saying AI tag.state is equal to state, and then if it is, we'll return, making it not run any more of the code that is within the function. Now we want to run a function for when we leave the state. We'll then change the state and run another function for entering a state. So we just want to create 2 more functions called static onState leave and static onState enter. Inside of these 2 functions, we're going to ask for a world, which is a ut.world, an entity, which is a ut.entity, and a state, which is a game.ai state. You can just copy this and paste it into the onState enter function. Now here we can say this.onState leave. We'll pass in the world, the entity, and the state. Then we'll play the onState enter after we change the state. And to change the state, we'll just say AI tag.previous is equal to AI tag.state, and then AI tag.state is equal to state. Now we'll create another function for the onState update. We'll say static on state update, Inside of here, we'll need a world, an AI tag, an entity, and a transform, which will be a ut.core2d.transform local position. Now inside of here, we're going to play the attacking code, but we don't want to place it directly in here. We're actually going to create one more function called static should attack to hold our attacking code. We can go ahead and copy and paste our attacking code into this function. And now we need to place the variables required to get this to work. So we need a world and an entity. Get rid of all of the this dots on your world. Now we're also going to set up another variable called let stop attack, which is going to be a boolean that's set to true. And this is going to be for determining whether or not we should continue attacking our player, and if we should stop attacking our player, we should change the state from an attacking state to an idle state. So first we'll say this.change state, and we'll pass in the world, the entity, the AI tag. We need to pass the AI tag into the should attack, so we'll go back up to here. We'll say AI tag, which is a game.ai. Pass in the AI tag. And then pass in the state you want to change to, which is game.ai state.attacking. And if we were able to perform an attack, we want stop attack to be set to false because we don't want to stop attacking. And if stop attack was not set to false and we are currently within the attacking state, we want to change our state back to idle. So we'll say if stop attack and AI tag dot state is equal to game.ai state dot attacking. If both of those are true, we'll say this dot change state to world entity AI tag and then game.ai state dot idle. So we need to run our should attack function. We can just go ahead and get rid of all of our code that we had put in for manually moving the AI. And inside of here, we'll just say AI input system dot on state update, and we'll pass in the variables that it's asking for, which is a world, an AI tag, an entity, and a transform. Which we aren't currently pulling yet, so let's just pull it from our for each. We can say ut.core2d.transform local position, and we're going to store this inside of a transform variable. Then we can pass that variable into here. Now let's run our should attack function inside of our onState update function that runs within our unupdate on the this.world.forEach. So we'll just say this.shouldAttack and pass in the world, the entity, and the AI tag. We can also get rid of this transform and pass the transform in through here. Then go down to here and we'll just pass in the transform. So transform, which is a ut.core2d.transform. Cool. Now let's set up our patrolling system. To do that, we'll create a new function. It'll be called static should patrol. In here, we'll need a world, which is a ut.world, an entity, which is a ut.entity, and a transform, which is a ut.core2d.transform local position. We'll also need the AI tag. Within our should patrol function, first thing we're going to say is if AI tag dot state is equal to game.ai state.attacking, we want to return, because if we're currently attacking, we do not want to stop attacking and start walking away from the character unless the code says we should. So if we are not in the attacking state, we'll want to check if we can walk left or right, and to be able to check whether or not we can walk left or right, we'll actually go into our game services file. And inside of here, we're going to create two new functions for determining whether or not we can walk left or right. So we can say static can walk left. And this function is going to require a world, a transform, and in here we're going to say let underscore hit result ground equal ut.hitbox2d hitbox service hit test, and here we're going to pass in the world. Then we'll pass in the vector3 position that we want to be hit testing against, which for this one will be the ground, which is slightly below the feet of the player. So we'll say transform.position.add, and what we're going to add is a new vector3. This vector3 is going to be to the left of our player, so we'll put a -1 on the x, and then we want to go slightly below the player's feet, so we'll say -0.5 for the y and 0 for the z. We also need to pass in the camera, which we already have a function inside of our game services for returning the camera. We have the static get camera. So we can just say this.getCamera, and we'll pass in the world that we want to get the camera off of. Now we can just copy and paste the hit test ground, and this one is going to be hit test wall. And instead of being on the ground for the wall, we're actually going to check on a -1 and 1 instead of -1 and -0.5. We'll use a +1 on the y. Now that we have our two variables for the wall and ground hit test set up, we're going to say if !_ hit test ground .entity hit .is none. So if the ground entity hit is none is false, meaning there is a ground, and the _ hit test result wall .entity hit .is none is true, meaning there is not a wall in the way and there is a ground to walk on. If we're able to confirm this if statement, we'll return true. And if we're not able to, we'll return false. Now we can copy and paste this, call it can walk right, and the only thing we'll want to change is from a -1 to a +1 on the x-axis on the vector3 that we are adding. Now that we have both of these functions set up, we can save our game service file, go back into the AI input system, and to the should patrol function that we were setting up, and inside of here we're going to say if game service .can walk left, pass in the world and the transform, Or if GameService.canWalkRight, pass in the world and the transform. If either of those return true, we're going to change the state to the patrolling state. So we'll say this.changeState, pass in the world, the entity, the AI tag, and the game.AI_state.patrolling, because we want to switch to the patrolling state. Now we can go into our onState enter. If we enter the patrolling state, we want to do some code. So we'll say switch. And what we're going to be switching over is the state that we're passing in. Now inside of here, we'll say case game.AI_state.patrolling. Add in our break. And now if we enter the patrolling state, we want to add the patrolling component that we set up earlier inside of the editor. So we'll say let patrol equal new game.patrol. Now we want to add this patrol component to the entity. So we'll say world.addComponent data onto the entity. The data we want to add is the patrol. We'll also set up the same switch statement inside of onStateLeave, but instead of adding the component, we're going to remove the component. So we can just confirm that it does have the component by saying if world.hasComponent. We're looking on the entity for the component. The component that we want is game.patrol. If it has that component, we're going to remove it by saying world.removeComponent. The component we want to remove is the game.patrol. Now, before we actually set up the patrolling system, let's just confirm that our attack system is still working. So we can save our file, go back into the editor, click on play, wait for your game to load up, and when it does, walk over to one of your enemies and see if he is still able to attack you. Confirm that it's still able to do the full combo when standing in front of him. Excellent. Now that we confirmed our game is still working with no errors, we can go back into our editor, and we're going to create a new system called a patrol system. So right-click, create, tiny, TypeScript system, and name it patrol system. Go ahead and open that file up. And inside of here, we're going to be doing a for each. So we'll say this.world.forEach. And the components that we'll be looking for are a ut.entity, a game.input, a game.movement, a game.patrol, then a ut.core2d.transform local position, and we'll also need a game.ai. Now we'll name these entity, input, movement, patrol, transform, and AI. Inside of this update, we're going to do a switch statement over the direction of our patrol component. So we'll say switch patrol.direction, and we'll have a case 0, a case 1, and a case -1. So say case 0, break, case 1, break, and case -1, break. So we'll set up case 1 and case -1 first because they are more simple than case 0. In case 1, That would mean our direction is equal to 1, meaning we should be walking to the right. So, to walk to the right, we're going to say if GameService.canWalkRight, pass in this .world in the transform. If we're able to walk right, we're going to say InputService.move using the input movement, and the direction we want to move is new vector 2, 1, and then input.axis.y. Now we're going to set our patrol.direction to 1 to let it know that we're moving in the 1 direction. Now let's put an else. If we are unable to walk right, we want to set our movement to the idle state. So we can just copy and paste this, change direction to 0, and change the vector 2's x also to 0. The case -1 is going to be the exact same as case 1, except for instead of can walk right, we'll use can walk left, a -1 on the movement direction, a -1 on the patrol.direction, and we are done with the case 1 and case -1. Now for case 0, which means we are in the idle position, we want to check if we can walk left or walk right. But we also want to walk in the position that we are currently facing. So if we are facing right, we want to check whether or not we can walk to the right before checking whether or not we can walk to the left, and vice versa. To do that, we're going to get the scale of the character. So we'll say let scale equal this.world.getComponentData. The data that we want to get off of is the entity. And the data that we need is ut.core2d.transformLocalScale. Now that we have the scale stored in a scale variable, we can say if scale.scale.x is equal to -1 and GameServices can walk left. If both of these are true, we're going to move our character to the left. So we can just copy and paste this into here. Now we're going to copy and paste all of this, type in else, then paste this. So we have an else if, and on our else if, it's going to be a +1 on the scale's x, and we're going to be checking for walking right instead of walking left. And if we can, our patrol direction should be 1. So we need to go up here and change this patrol direction to -1. Now we're going to put another else if that's going to check the left and the right regardless of what the scale is. So if we were facing the left and we are unable to walk left, or we are facing the right and unable to walk right, it'll just default to checking either one of the sides regardless of what your scale is. And to do that, we can just copy and paste the one that we wrote earlier. So copy this, type else, then paste. And then we can type another else, paste again, and change this to a left, and this to a -1, and this to a -1. Now we just need one more if statement for if none of these were able to go off. So if we should be in an idle state or unable to walk at all. To do that, we'll set our movement to 0, and then we need to remove the patrolling component, and then change the state back to idle. So we'll say, if it has the component, this.world.hasComponent, the entity that we want to check, and the component we are checking is game.patrol. If it does have a patrol component, we're going to remove that component by saying this.world.removeComponent off the entity, and the component we want to remove is game.patrol. Now we want to change the state of our entity back to the idle state. So game.AIInputSystem.changeState, pass in the world, the entity, the AI, and the game.AIState.idle. Let's go back into our Unity editor and see if this works. So go ahead and click play, wait for your game to reload. You can see our character is not moving, and I think that's because we forgot to actually run our shouldPatrol function. So let's go into our onState update, which is right here. And after this.shouldAttack, we'll say this.shouldPatrol. Pass in the world, the entity, the transform, and the tag. Let's save again, go into your editor and click play, and see if this works. Wait for your game to reload. Once it does, you'll see that your enemy AI is walking back and forth. We can walk over to him and see if he's able to attack us. You'll see that he is attacking us, but he is not stopping his movement. To get him to stop his movement, we'll need to go back into our scripts folder, go into the movement system, and inside of here, click enter a few times and say if this.world.hasComponent, the entity that we're checking, the component that we're checking for is the game.attack component. So if it has an attack component, we do not want to be able to walk. We'll also go ahead and check if it has a dying component, and if it does, we also do not want to be able to walk. So we'll say this.world.hasComponent, entity, game.dying. So if it has either of these components using the OR statement, we're going to set its velocity to 0. So we can just go into where the idle is, copy and paste the idle statements, save, go back into your Unity editor and click play. Let's walk back over to him and see if he pauses when he attacks us. Oh, he paused alright. Paused and errored. So it says we already contain an instance of ut.physics2d.setVelocity2d. That's because we need to return right here. So we'll add in a return, save again, go back into our project, click play. Let's walk back over to the enemy again and see if he's able to attack us. You'll see that he pauses when he attacks us. When we walk away, he continues going back into his patrol state, and we go back to him, he'll start to attack us again. If we walk behind him, he'll go to patrol again and then attack us when he reaches us. He's also able to kill us and our player is removed. Let's refresh and see if we are able to kill him. Let's go back into our Unity project. We're going to set up some code for spawning some more enemies in. So go into your scripts folder. We'll go into the Games Manager Service script. And this is just tester code, so I'm just going to copy and paste it in. We have a input for when you push U, it's going to spawn in the enemy. And you can see that this is giving it an error. The reason is if we go into our game services, we can just make this a public instead of a private. We also need to add in this getRandom function that I added in. So let's go into our game services file and add in the getRandom function. It's a pretty simple function. All it is static getRandom min max, and it returns math.random times max minus min plus 1 plus min. Using that, we'll be able to get a random position when we push U and place it onto our entity. Let's go back into the project and click play. We can now spawn in some more entities. You can see that they aren't bouncing off of each other and they just keep continuously trying to walk into each other. An easy way we can fix that is just by going onto our enemy and adding a hitbox2d component. And we can pretty much copy the same variables from our box collider 2D. So our size on the Y is 1.62. The size on the X is 1. And our X should be negative 0.5. Now that we have this added onto the enemy group, let's save it. Let's save it. Click play. Spawn in some more units and see if they bounce off of each other. It's a little hard to tell with that spawn group that we got. Let's try it again. And of course they landed on top of each other again. What's the actual chances? Okay, cool. That confirms that it's working. Let's drop down in between these two guys and see if we get any other errors or anything. We didn't get any errors. Let's increase the health on our player so we can survive for a little longer. We'll put his HP up to 1,000. Click play again. Let's spawn in some more units. Drop down. Confirm everything is working. Okay, so we got an error on our ut.physics2d.addImpulse2d saying we already contain an instance of this component. So let's go find where we add the Impulse2d at. I know that we add it for our attacking system and our jumping system, so let's go check. We do not check for the Impulse2d on the attacking system, so let's just check it before we add it. We can say if world.hasComponent destructible int, the component that we want to check if he has is a ut.physics2d.addImpulse2d. If he does not have the component, we'll add the component, and if he does have the component, we'll just set the component data. So just change add to set. Now let's go into our movement system, where our character jumps at, and we also need to do the same thing. So you can just copy and paste this. Make this dot world, this dot world. This should be entity. Cool. So if it does not have the component, we'll add it. If it already has the component, we'll just set the data onto it. Let's go back into our project and click play. Spawn an enemy in. We confirmed we're able to kill him, but one thing I want to do is make them a little easier to kill. Let's lower their HP to 30 so we can kill them in one combo. Let's spawn a few enemies in and start attacking them to see if we get any more errors. The game seems to be working just fine. Let's spawn a few more enemies in and just confirm that no errors are going to happen. So this is it for this video. I hope you enjoyed it and I hope you were able to learn something. If you were able to learn something, consider giving a like and a subscribe to the video. If you have any questions or comments you'd like to ask or leave, feel free to do so below. But until next time, have a wonderful day and I hope I'll see you in the next video.